Okay, so hello everyone. This is Francis Orozco again, and we'll be continuing our quest in solving the mock problem set of the National Olympiad on Informatics. So this, so for today, I'll be making three videos. This is the last video. We'll be solving the reverse trip to Jerusalem. Hopefully by tomorrow, I'll be solving the traveling supermodel problem, which involves dynamic programming and some harder concepts that is really challenging, to be honest, for a high school student, because dynamic programming, the concept of it, okay, is taught in higher computer science classes in, let's say, in the University of the Philippines, Diliman. It's really a third year college student computer science concept. So hopefully I'll be keeping things as simple as possible. Okay, so let's go for the trip to Jerusalem. So for the trip to Jerusalem, we have two numbers, actually two sets of input, n and c of I. N uh, is from 1 to 200,000, okay, and then c is from 1 to what? N minus 1. Okay, n minus 1. We have n minus 1 eliminations. Okay, so we'll be having a reverse trip to Jerusalem. Okay, so what would be the positioning? Okay, so we have Todd, okay, which is U. Okay, we have Todd, which is U, which is denoted by, okay, something simple. We have this, okay, and then we have N friends. So to the left of U is P of 1, P of 2, dot dot dot, to P of n minus 1. Okay, if we place Todd at the leftmost part, okay, we have Todd, P of n minus 1, P of 2, and P of 1. Is that correct? Oh, okay. For for simplicity's sake, just forget what I've said. Okay, so this is Todd, which is position 0. This is position 1, position 2, and position n minus 1. Okay, that is to the left visually. If we flip it, Todd, P of 1, P of 2, P of n minus 1. Okay, this is pleasing to the eye, right? To visualize, we flip the array, but the mechanics are still the same. Okay, wherein, let's say, a person has been eliminated, to the left of it is we increase it just by 1. Okay, mod, let's say, mod n minus 2, right? Because, or mod n, because the player has been eliminated. Okay, so first we'll be having a naive algorithm for this. Okay, so this is problem number 6. Okay. 106. And then we'll be adding class solution. Okay. So we'll be adding a main class. So we have a scanner. Okay, and we'll be getting 10. Okay, we'll be declaring an array which is appropriately named C. Okay. Next, we get the inputs of the n-1 elements. This is the previous one. Okay. I want my variables to be consistently named. Okay, and we close the. Okay. Next, we have an array list, and essentially this holds the list of people, 0 being Todd, 1 to n-1 being the persons, the other persons. Todd's friends, I believe. Yeah, Todd's friends, or your friends, because you are Todd. So you add the numbers. Okay, from 0 to n, right? So don't forget to import the array list. Okay, so next I used a variable pos, which determines the current position of the chair. And then we iterate the n-1 eliminations, where we have pos is equal to pos of ci, or in this case c of ctr, mod what? First is n, mod n, and then mod n-1. So first elimination is n, and then we have n-1, then n-2. So essentially it's n minus ctr, and then we remove the person. Okay, and then if the number is 0, then we have to output yourself or Todd. Okay, so our test data is 5 1 this is 2, and if this is 2 1, you must be that. Okay, so oh, I'm sorry, should be that. Okay, so let's do this one. Okay, okay, so for the both test cases it passed. How about the judges test cases? Actually, our naive algorithm is running very slowly. Okay, so as you would notice in the results, we have 47. The judges have 47 test cases, and 2 of which were terminated due to a timeout. So essentially, doing a naive algorithm using generics in Java is, well, pretty much time consuming for the program run. So the next option is I opt to code it in C. And for the guys at NOI who provided this nice editorial notes for problem 6, okay, the reverse trip to Jerusalem. The reverse trip to Jerusalem is just a variation of the Josephus problem, okay, wherein this is a bloody problem. Um, the persons are aligned in a circle and they are to commit suicide or something. I'll just click on the link. So okay, oh, they are they aren't committing suicide, they were executed. So and then actually the normal variation of this problem is that there are no values of ci, there's only a value of, let's say, I or c, wherein, let's say, if I is equal to 2 or c is equal to 2, every second person will be killed in the circle. So a man named Josephus calculated the problem and positioned himself in the circle in such a way that he would be the last person standing, and the condition for the last person standing is the one that is given freedom. So the problem is really bloody. Okay, so for the guys at NOI, they have an optimized solution using links, okay, using a tree, and using math. Okay, so in using math, okay, we just have a sequence C1, C2, C3 up to C of n minus 1. Okay, So the eliminations, I believe, is first one is C1 and second one is C2 and so on and so forth. So the positions are C1, okay, plus 1 mod n. This is a part that you will be safe. Oh wait. So we have n players for the sequence C1 up to Cn minus 1. What happens after the music plays and stops the first time? Okay. So okay, let's go back to the problem. Okay, for the first round, all n of you will be in a circle. Okay, so after the first music stops, okay, the position C1, okay, mod n has been eliminated. So the next person who would be receiving is C1 plus 1 mod n. Okay, so after the first elimination, this is after the second elimination, and by the following case, this is the after, so after the first, second, n minus 2. Okay, n minus 2 elimination. So their approach is just the reverse. Okay, so you will be eliminating from n. Uh, you will be eliminating from the first one up to the n minus 2. So essentially you will start off at n. They just reverse the um, formula because of the modulo. You have to start small to big. So the formula is just uh, n. So this is n plus c. Okay, c of I. So this is denoted by n minus I plus 1. Okay, mod n. Okay, so for the first elimination, this is n minus 1 mod n. Oh, sorry, this is n. And then for the second one, it's n minus 1, and for the third one, is n minus 2, and so on and so forth until we reach 2. Okay, so this is just the reverse. Okay, so actually, it's better if we implement that the algorithm. Instead of puts, we'll be using printf. We delete this, uh, except for stdio.h. I guess this is implemented in C++, but we'll be using C for this case. So we have and I really don't get it why this one is 200,010, but if we just use 200,000, So essentially for n, it is runs in on time. It's linear. It's that efficient. Uh, let's position the notepad in this manner. Okay. Move. Okay. So we'll be reversing staff of enemies. So this gets rid of the array list. Okay. It's more optimal than the naive algorithm I composed earlier. God, we must so let's use the pirate pad. Just have to refresh it. Okay. And then let's go back to our virtual machine. What happened? What happened? Okay. Refresh again. The pirate pad sleeps for some time. Okay. Okay. Let's have a new file. Whoa, 21. What's that? Okay. Let out. 5. What was the test data again? One, two, two, four. Okay. Again. Okay. Okay. So we'll be running as is. So this time we'll be using C. Okay. Actually, I've solved it a couple of hours ago. I'm just repeating the process. So yeah, we passed the specifications test cases. How about the judges test cases? Okay, so for the judges, 47 test cases, okay, they all pass. So the guys at NOI did it correctly. Okay, and I've simplified their um, algorithm. So that's for problem 6. So for tomorrow, um, I'll be doing and explaining the traveling supermodel. What was the name of the problem again? The traveling supermodel problem, which involves very high level computer science concept, dynamic programming. Okay. So hope you enjoy. So this is Francis, okay, and see you tomorrow hopefully. Thank you for watching.